In this presentation, we're going to talk about a technology which can be used to recover typographical and layout information in OCR and therefore recover the information that's encoded by typography in written sources. We'll briefly talk about the kind of information that is in fact encoded using typography, taking typography in a broad sense. We're going to look at two actual examples from our own work on language documentation materials, and then introduce the technology that we have used to try and solve these problems, which is called Alto. Talk you through how we address those two problems, and then finally we'll say a few words about other possible uses of this technology. When I'm talking about typography here, I'm thinking about any aspect of how information is presented on a written page, where the information is, how bits of information relate to each other, and so forth. And as we know, these kinds of typographical aspects of a document can code specific information. So we use typeface to indicate emphases. Information hierarchies can be encoded in ways like indentation, levels of indentation, and how elements are positioned relative to one another can be meaningful. Are things aligned or not? And in all of these cases, space, or except for the first one, space is meaningful. But as we know, standard OCR, although it's a very powerful technology, very valuable technology, doesn't necessarily capture this information. Can we do something to try and improve this? First, let's look at a couple of examples quickly to see the state of these problems. First of all, this is part of a page from Geoffrey Heath's dictionary of the Nunga language, and you can see there are different levels of indentation. In fact, there are three. And this codes information. It's meaningful. The leftmost items are head words, so each time you see something that's further left, that means this is a new entry. Then the next level of indentation shows you, as you can see about in the middle of the example there, shows you numbered subsenses, but as you can see in the first entry, it also has derived forms. And then there's another level of indentation which has things like notes and run-ons of the first of the opening entry. So these are three different levels of indentation, three kinds of information, but they're based on white space, and basic OCR is not going to recover that because it's interested in finding characters. Here's another example. This is again from Heath's documentation of Nunga. This is from his volume of texts. What's interesting here is that what's aligned. So this is a standard presentation of linguistic material, aligned interlinear text. And as you can see here, there are two lines. There's a line of Nunga forms, there's a line of translations, and the bits that go together, that's indicated by alignment. They're left aligned. Again, this is based on white space, and standard OCR is not going to distinguish this. It's made even a little more complicated here because, as you can see in the second line, in one case the translation has been omitted because it's assumed that you can recover that. So we won't have, with standard OCR, it's very hard to actually get this pairing correct. The technology we're going to talk about, which can be used to address these kinds of problems, is called Alto, which stands for Analyzed Layout and Text Object. And Alto is a set of XML schemas, or well, one really, but it has some variants, and it is a way of describing layout information of digitized pages. And it's supposed to be precise enough that you could reconstruct the appearance of the original on the basis of this. So for each visual element on the page, you get information about its position and its dimensions. And it looks something like this. This is a chunk from an Alto file, the layout section, which is where all the important information is. And you can see the kind of objects which it refers to. And you can see that they all have width, height, or horizontal position, vertical position, and so forth specifications. The ones we'll be looking at here are text lines and strings, and you can see that for a string, that's where the content is. So how do you get this kind of representation? Well, Some scanning software will give it to you. What we actually used here is Tesseract inside the PyTesseract wrapper, which has a function image to Alto XML. And that's what we used to get our XML representations. The output of that function validates against the Alto schema, so it's well-formed XML, and you can manipulate it in ways that you would normally manipulate this kind of stuff in Python or whatever coding environment you're using. Standard XML parsing tools will work with it, so you can extract the necessary data. So, what about our problems? First of all, the indents in the dictionary. So what we're interested here in is the horizontal position, the offset for each line. The default unit of measurement here is pixels. This is very high resolution, and in fact things are not going to come out at exactly the same value for various reasons. So things that we perceive as being the same will not be the same in the XML numbers. To do with things like just minor printing inaccuracies, that the page wasn't put square on the scanner, these kinds of problems. So to get this to work, we used a clustering algorithm which grouped things together. Clustering algorithms are very powerful. This is, really a sledgehammer on a walnut, but it did the job. And clustering algorithms group data. We used an algorithm called dbScan, and it had particular advantages here. First of all, you don't need to say how many clusters you're looking for to use dbScan. It will find points, central points, and create clusters around them. And it's very good at how it treats outliers. It throws them out, says they're noise, and gives them a cluster value of -1. So this is the algorithm we used. We needed to tweak slightly the parameter to get the right distance between the centers of the clusters to get the results we wanted, but that worked fine. So the result of this is that we have cluster values we had the set of lines on our page. For each line we had a cluster, it belonged to a cluster. Now the numbering of the clusters didn't correspond to the indentation because the cluster values are assigned according to what the algorithm encounters first. So the order of indents on the page was not the order of indents in terms of horizontal position. And we needed to just check that and adjust the values, but then we had a set of information where we had for each line, we knew what indentation value it had, and we could feed that into other representations and other processing. The second example, interlinear alignment, again, we're looking at horizontal positions, but this time we're looking at horizontal positions in pairs of lines and seeing what information is stored at each pair, what aligns, and therefore what makes a pair. Again, we had to tweak the tolerance that we allowed between places to get the right groupings, but this was straightforward. And here we could identify where translations were missing because there was a gap in the alignment. There was something just didn't have anything matching in the translation line. Because Heath only omits the translation where it's easily recovered. Typically it's immediately preceding, but sometimes it's a little bit further back that you need to look, but it's always within a single text unit. And as we were building a list of pairs of forms and meanings incrementally, we could look back and fill in the gaps. So working from the example we had before, what we end up for the second line there is this list of form and meaning pairs, where we've aligned everything, said what lines up, and we've filled in the gap. You can see that there are some mistakes in the OCR of characters here, and in fact we have to admit that for these materials in the end we were not able to use OCR as our basic way of processing them because things like the superscripts and subscripts were just too problematic. So these are examples that show that Alto is very useful in enriching the kind of information you can get from OCR. You're getting a well-defined format, it's encoding the layout, the information can be recovered. In fact, the technology is quite a lot more powerful. These are really simple examples of what can be done with it. A couple or at least one use that people have put it to, is in using annotation tools, where you see an image of a page and a text representation that you can edit, and to track, keep the positioning in those two sources corresponding. The original image is the original source has an Alto representation which is fed into the editing tool so that you keep in the same position. And this is what the transcription tool at Trove newspaper collection, how that works. Another example of this, if you feel the need to have a tool of your own to do this kind of stuff, the National Library of the Netherlands have developed one called Alto Edit, and that's available on GitHub. And now Nick is going to say a few words about a couple of other possible uses of this technology in working with written legacy sources.
So as an example of the kinds of projects that the Alto and similar technologies will allow us to undertake, here's the Bates project. This has been going for the last few years, and it has put online 26,000 pages of Daisy Bates materials, and you can see there's a textual version which is a TypeScript and one which is a handwritten manuscript. Now this kind of document does require a lot of hand work, but we think that using Alto we probably could infer a lot of information from documents like this and make it a bit easier to get them online. And this has led to a LEAF project which was just funded for the next 3 years, called Ningan. Ningan's the word for echidna in Nunga from southern Western Australia. And this will be a platform for presentation of all primary sources of Australian languages that we can put into it. And it will have a pipeline, so we'll have ways of OCRing, scanning OCRing and putting documents in. And of course, as you can imagine, the sort of technology that you've just heard about in Alto XML will be really useful for putting the documents up with text and then doing things like creating PDFs with text and extracting information from the page automatically. Because we hope to have lots of documents, we want to be able to do this as much as possible automatically and not require a lot of hand coding. So that's a project that we will be running for the next few years, and watch this space. Thanks very much.